Hi, Sri. Good evening.
Hello,
Hi, Sri. Good evening.
good evening.
Hi.
Good evening, ma.
Hi, Sri. Good evening.
Hey, Amshi. Good evening. Okay, let us start. So, we discussed about the EMR part and we'll continue that. But before that, to manage this EMR, we also need to know about some part of PySpark as well. So, we learned about Python, the foundation for PySpark already. And let us see some PySpark hands-on also. Then we'll come back to the EMR once again and we'll try to see how to, because to like create any big data pipeline, we should know PySpark uh, coding also. So let us try to see that. What is PySpark and why we PySpark is very popular in the market in the big data like projects. Just give me a minute. So to understand about this PySpark, it is Python with Spark integration. We also need to understand about what is Spark first of all. Why Spark became popular? What was there before to manage big data before Spark was invented? And let us try to understand. When I say big data, there are so much amount of data available in the market, but when we call a data as a big data, what are the main factors we consider a data is a big data? We cannot simply say 1 GB or 10 GB as a big data, even 100 GB also. So big data in the sense there are different characteristics or factors. The first characteristic is volume. High volume of data. It should be petabytes of data. And my data which is in petabytes, then only I will call that as a big data. Similar to that, I also need to able to manage terabytes, petabyte of data plus high speed data ingestion is important. So high speed data ingestion means my data when you are loading into the big data environment, I should be able to load and retrieve in the same velocity, same speed. Even it is petabytes of data within fraction of milliseconds, I should be able to load it. At the same time, in fraction of milliseconds, I should be able to extract it. And variety, this is one of the very important factor or characteristic why big data became popular because the unstructured data, semi-structured and quasi-structured data has been generated after big data came on the market and people started even utilizing this data in the place of structured data to reduce the storage and cost and at the same time to fast processing to process the data faster. This particular semi-structured and also like quasi-structured data also started helping like JSON files, Parquet files, XML, Avro, ORC, these are all fall under semi-structured. At the same time, during the big data generation, the unstructured data also is playing very important factor. The most of the PDFs, documents, images, voice, all these also part of your big data. And one of the varieties where nowadays people are even considering a image also a data, a voice also a data. So a voice analysis, the sentiment analysis. Your audio call will be recorded to analyze later. When you are talking to any call center executive, you will get a message. Your call will be recorded for testing and quality purpose, right? There'll be a message. Why? Because they will try to see whether how the customer is reacting to the call center executive response, and they will analyze the customer experience also by extracting some sentiment from the voice. So we need to even process image or a document or a video also. So big data means not like only structured data here. It is a combination of many types. And veracity. Veracity means data uncertainty and quality also one of the biggest challenge. So we need to maintain the high veracity, high quality of the data. And value, finally. What is value means how your data is getting utilized for analysis. You may build a big data environment, but that big data environment requires a final end users. Without the final end users, I cannot go and say my data is getting utilized, because the data which is like generated should be utilized for the company's development and career growth, and we should know how the data is getting utilized and how to help the teams to like use the data, and also need to get some feedback from that particular teams to optimize or improvise the data also. So this big data, when initially it came into the market, the Hadoop was one of the tool where HDFS and MapReduce both were giving the flexibility to manage this data. Someone joined. So we need to see how this MapReduce was having some limitations, because how Spark came to the market, there are some of the reasons. So the first one is processing speed and processing type also. MapReduce was only capable to perform batch analysis. It was not capable for live streaming, machine learning, and graph processing, all this stuff. Plus, MapReduce was using a disk-heavy IO operations, which were the main reason for the delay and latency. But Spark will process the data directly in RAM, and latency, the latency was very high with MapReduce. Even I built some of the MapReduce jobs also in 2012. my initial days of big data was with MapReduce, and later even I switched to Spark because of MapReduce limitations. Even my jobs also used to run very late. So, but there was no option. So we used to wait for hours and hours to the job to complete. Then later, when we moved to Spark for the optimization, we experienced so much of improvement, because the Spark was capable of doing many things, directly processing in RAM, and even the latency was also in very low. In milliseconds, we used to receive the response. And the complexity with MapReduce is where it is very difficult because of Java API. We need to understand if any issues will arise, you need to know how to debug, and you should know Java also. Most of the frameworks initially in Hadoop environment were Java frameworks. That is also one of the reason many people hesitated to move to big data. Even I was also having challenges because I am not a Java developer. So later when Spark came to the market, Python and Scala, these two languages slowly replaced like Java also. And even Scala also not available now. Only Python. Slowly, Java, Scala went behind, and Python captured the entire big data market with Spark also, PySpark. So Spark with Python integration, which started, and that gave more flexibility and in-memory and fast analytics to speed up the data processing, big data processing. And Spark is 100 times faster than Hadoop MapReduce and 10 times faster than the disk. Since the data will be directly stored and processed in the RAM, Spark will avoid the IO operations which MapReduce was using. The same process was not followed by Spark. Spark directly processed the data in the memory only, not like from the disk IO operations how MapReduce was using. So the Spark is coming up with different components. The Spark components like the Spark core engine. On top of that, you will see the Spark SQL for structured processing or batch processing. And Spark streaming is available for live data streaming. And Spark MLlib for machine learning. And we also have Spark RDDs for unstructured data processing also. And graphics is available for social media applications, graphics processing. So all these together in single unified platform with big data capabilities where you can process and where MapReduce and HDFS were managing or ruling the big data world. Spark came into the market and it is slowly replaced MapReduce, and Spark and HDFS are the combination now. Even the HDFS also, earlier people used to leverage the on-premise servers. Now the on-premise servers were replaced by cloud servers. The big data cluster which was on-premise, now we are using a EMR, a big data cluster in the cloud, because the data which you are going to process requires a ready-made big data environment. So we cannot depend on any particular Hadoop administrator. So every company now slowly migrating to cloud big data lakes by leveraging this EMR and HD Insight, this kind of ready-made services. And coming to Spark side, Spark can process weblogs which are unstructured data by storing in RDD. A Spark can also process structured data which we can directly go and connect to a database tables and pull and process. And coming to Spark, during the Spark data processing, once you submit any Spark job, that requires a Spark cluster to be available. The Spark cluster is a pointer to process your data. So to the pointer to the Spark cluster is Spark session, which we need to create in first. Once your Spark session is ready, you are good to go and submit all your Spark jobs, and this Spark session will be used to convert your Spark code into multiple tasks, and this will be managed by the a mission called driver node that is going to manage a group of worker nodes which are called executors. So they will try to run the actual jobs. So worker node and executors are mainly going to run the actual processing, and this will be managed by the driver node. So all data will be in the RAM, and where we do not need to run anything in the disk, and the worker node and executors will coordinate with each other in the direction of driver node, and your data will be processed faster, and all will be managed in the RAM only. And this cluster manager, which is going to manage this entire like a Spark big data cluster, it can be managed by any of these. So one project will use based on their like a requirement. It can be a standalone cluster, or it can be Hadoop Yarn manager, or it can be a Kubernetes cluster, or it can be Apache Mesos, which is a dynamic cluster manager. So anyone is fine. So, but all these generally people used to leverage earlier, but nowadays even this is managed by the cloud service provider only. The EMR will have its own inbuilt cluster manager, which we do not need to go and manage it. And Spark session was the modern like entry point for Spark jobs. The earlier one, the legacy one is Spark context. Now it has been become legacy and obsolete. The Spark context has been replaced by Spark session now. Internally, Spark session also will wrap Spark context only, but the modern Spark environment, starting from 2.0 version onwards, you will need to create a Spark session, not Spark context. Before that, if you are using Spark 1.0 and all, you need to create a Spark context. But the most recent, starting from 2.0 onwards, you do not need to create a Spark context, and you need to create a Spark session by using a Spark session function. A Spark object will be created, a session object, and using this only you submit all your Spark jobs. Spark dot, and you can submit most of the jobs. And in this Spark like driver also, which is going to manage the entire Spark cluster, will be in client mode and cluster mode, and the driver will use the client mode when any job is submitted, and this is basically suitable for debugging and interactive execution, whereas in production we generally go with a cluster mode only, because normal development activities and all you can manage with the client mode. But if you go to production, the client mode is not going to help us. You must go with a production environment with cluster mode only, because the cluster is going to have more capacity than the client mode. And all this generally, if you go and see, most of the cases the Hadoop administrators will take care of. But nowadays, we as a data engineers, we should have some knowledge on this. If you don't have a knowledge, people will not consider you as a big data engineer. That is what happening now. You got it right? What I'm trying to say? All of you? Yes or no? The fundamental knowledge. People, when you go to any interview, they'll ask you, explain me about Spark architecture. What are the different nodes available? What each node represent? They will ask you. They will ask you, definitely. If you go to any data engineer jobs, some people are interested to find out whether you have this fundamental knowledge or not. So what is a client mode? What is a cluster mode? Client mode is nothing but your laptop. You go and connect your laptop, right? From your laptop, you connect to a Spark job, you will install a Spark software, you will install, and you will connect with your laptop, where your laptop will work as a cluster. That is client mode. But when you connect with any other cluster from your laptop and you manage, that is called cluster mode. And you submit the code, and that will be executed in the server environment. And the server will be available, maybe EMR. EMR is basically managed by Amazon team. And you will create a Spark session and you connect to that and you submit your jobs. Then that will be a cluster mode. Okay. And coming to like managing this particular Spark data with the environment, RDD is one of the fundamental data storage unit, which is called resilient distributed data set, and immutable, which cannot be modified. So this is basically suitable for unstructured data. And even structured data are most of the cases we use for unstructured data. And we also have data frames here. How we have Python pandas data frames. Similar to that, we also have a data frames in PySpark also. And this database also, data frames and this RDDs will be distributed across the cluster in different nodes. If my EMR cluster, if you remember, we created a EMR cluster with multiple nodes. Correct or not, everyone? 2 node or 3 node. So one driver node and then one worker node and one executor. So more number of executors means your performance will increase. So your performance of your data pipeline or data processing will depends upon how many like executors are there in your environment, because they only will process your data. So when you are leveraging this big data environment, you also need to think about how many nodes required in your cluster, because your data will be distributed across these nodes. And data sets is one of the another data structure available in PySpark, along with data frames and RDDs. And these particular data sets are like very popular, like in 2012 to 2017, 18. Later we got data frames. So data frames became one of the fundamental foundation for the Spark, where you manage all the structured data using data frames only, the structured API. And this is a datasets API where you have a compile time safety only, but data frames are, you can store the data and you can use that for most of the data pre-processing and all, directly apply the functions and transformations if needed directly on the data frames. These data frames are almost similar to Python pandas data frames, and we can convert a data frame to a temporary view also, a temporary table. And if you are a SQL developer and you don't want to perform any data frame operations through Python or to PySpark, you can also convert your data frame into a temporary table, and you can apply the select queries on top of the table like this. Whatever I am doing here, I am converting my data frame DF to a table or temporary view called users, and on top of that I am applying the select statement, if you observe here. And this is going to run a select statement on this data frame, and it will return the results into the output into this results data frame. So this query what you are running, you are directly running on a data frame only, which converted into a temporary view. I hope you know what is a view, all of you. A view is just like a stored query. So when this will be majorly helpful, Spark is because whenever I am performing a the financial fraud detection, I want to flag all the credit card last 5 transactions in the last 6 seconds ago, whether any credit card fraud transaction is encountered. So for that, I can use Kafka plus the Spark structure streaming, where Kafka can capture these transactions in JSON form, and Spark can streaming can convert them into a group of rows and columns. And we can push into a Spark data frame to a Spark temporary view, and I can apply select statement on top of that. That is what generally will happen in any kind of real-time dashboards. Spark plus Kafka integration will try to pull the data, and that will be converted. The Spark structure streaming will be converted into a temporary table, and using that table we will try to connect to a dashboard, and we will populate the data. The real-time dashboards can be built using whatever you see here. This is, you can consider as a real-time dashboard. This may change whenever there are changes. assume the most recent two transactions are fraud transactions, we can see some change in the real time. So whatever you see here, the amount 5,000 maybe in Dubai, which happened, maybe a fraud because amount is very heavy. And this particular card ID, like 56 and 56, only two transactions happened. And whatever you see here, a London location transaction may be maybe a fraud. The system may be captured and tagged that as a like a fraud transaction. So the team has to, who is responsible for that, for the transaction monitoring, they have to be notified through some interface or to a dashboard where they will be monitoring. It should flag. So we also built an application called Eagle for the money laundering detection, similar to what I am talking now. So all the money laundering transactions on a particular day, our system Eagle is going to identify and flag. And those transactions will be highlighted in red, which are like we have a percentage cutoff. If it is 80%, which our system identified it's as a flag, it will be in the red color. From there is a range between like 50 to 80, it will be in orange. And again, it is like 40 to 60, it will be in yellow. So like that, we categorized the transactions. In our transaction monitoring system, we built this real-time product like a money laundering text engine. Our interface will flag like that. We use Kafka and Spark only. And Spark streaming, and I mean Kafka. So Kafka, will extract the real-time transactions through API, and those transactions will be converted into a Spark streaming data, and from there we'll push into a table so that we can process that like data into a group of rows and columns, and we can apply the ML model to predict whether that will be going to fall on a suspicious transaction or not. So that is how you need to understand how Spark can help in the real-time environment. Because I cannot go and say after 1 week that there is a fraud transaction or a money laundering transaction in a bank, right? Can I tell like that? It's 1 week delay. Will they accept it? If I go and say there is a fraud transaction after 1 week or money laundering transaction after 1 week, will they accept or not?
No.
No, nobody, even either you or me. If my credit card already flagged suspicious transactions, which means I am losing my money. Correct, right? So nobody will be ready for losing the money, right? So they are very critical. It can be fraud transaction or it can be a money laundering transaction. We are responsible if you are working for a team of transaction monitoring, you are responsible to flag that. Make sense, everyone?
Yes,
Yes,
sir.
sir.
Yes, sir.
Sorry. So to implement this kind of pipelines, we need to understand how to use Spark or PySpark. So how can I go and load? Assume that I have received some set of CSV files or JSON files, or my data which coming from Kafka may be converted into a structured data and pushed into databases like Snowflake or any kind of databases. And I need to know how to pull that data into Spark and then process it, and how to apply some transformations on top of it, and finally push into a dashboard connected tables. So to understand that, let us try to see some examples. So generally, so what kind of like just a minute. So what kind of file formats we generally see? CSV, JSON, Parquet, ORC is another type. All these where we read the data, and some part of data will be even come from the RDBMS also. If it's a big data, you receive the data from Hive Metastore, Hive environment, and sometimes in database kind of environments, if you are using, you will get a Delta Lake tables also. So my sources can be either this one or this one. Sometimes the streaming data also, which I was talking earlier, Apache Kafka stream, or it can be directly coming from Amazon Kinesis or Google PubSub or Azure Event Hub. It can be anything. So my data, if it is coming into one of any of the sources, I should know how to read and process. Just assume that I have some set of data which I want to process. So let me try to upload that data. I'll load some sample data here to process. So my file which I want to use here is the restaurant tips data. Copy path. I need to click on right click on copy path and use this path to load. It's already the same name here. I'm just going to give the same name. And before that, I need to load the Spark session which I was talking. Let me try to load the Spark session. So that is loaded, and create a Spark session. So I'm just giving the name of my Spark session as data frames, and which is as per my current environment. This will be getting executed as my local. So let us try to see. Once my Spark session is created, I can display and see what is my Spark version and all this stuff. This is what my Spark version, and which is my local is behaving like a cluster here, and app name is data frames which I just created. Now I want to go and load some data. To load the data, I will use this Spark session dot read dot CSV. So to read any CSV file, we need to use the read dot CSV function, and this particular data, whatever you see, this is the file which I uploaded, and this is the one here you are able to see. And when I run this, it will load the data, but however your data is not properly loaded. The columns also came as row, correct, right? Is this data correct, what you see here? Is it correct what you see here? Whatever you see, total bill, tip, these should come in the column headers, right? Yes or no?
Yes.
So what I need to do for that? Then I need to add a header true option. How to do that? I will go here and I will use the header true here. Can you see that? This property is important. It will enable if the file contains any column header, that will be used as a data frame column header. So let us override this. So now you can see here the data has been loaded, but how to see the top 5 or 6 rows? I will use the data frame name dot show is a function. If I don't mention anything, The default number of rows it will display is 20. See, it is already showing 20 rows. But if I want to reduce it, I can reduce. Maybe I want to see only top 5. So now it will show me all the columns but 5 rows. So what you see here, my data which is related to the restaurant bills, where you have total bill and the tip for that bill and the gender, whether the customer who visited is a smoker or non-smoker, and on which day they visited, and which time, dinner or lunch time, and how many people visited with a family. All these are captured here. Now I want to analyze this data. I want to see how many male customers visited, how many female customers visited, who are all the male customers, dinner time, how many people visited. I want to filter out. Then I will apply some filter function. But before that, I don't want to select all the columns. I want to select only few columns. So to achieve that, to filter by column, I use a select function. Data frame dot select, and I'll mention which columns I need in a square bracket like this. So there is no need to go in any order. So the order also I can rearrange them according to our requirement. So when I run this, it will pick up only total bill, tip, smoker, and the time. Only 4 columns it is extracting, which you can see. The other columns are not part of my output. Now let us try to see some fundamental metadata of this particular data frame. Print schema is going to show me what are the columns and corresponding data types. Whatever you see here, every column and corresponding its data type, it is capturing. Similar to that, D types also will do the same. And this is another function to see what are the data types of this particular data frame of each column. And describe is another function which will identify the fundamental statistics of each numerical column. So whatever you see, the numerical columns like total bill, tip, and size, you will see the maximum count, the total count. You also will see the average, standard deviation, minimum value, and maximum value. All these will be automatically calculated. Now, how can I add a new column? If at all I want to add a new column to my current data frame, I will go and use a function called with column. Already these are all the columns what available here. But at the end of this size column, after size column, I want to add a new column with the name discount after total bill. So we are using the with column function, and we are subtracting $2 from the total bill of every customer, so that we will see how the discount has been calculated. So you'll see here a data frame got created. So if I run this, you will see these are all the rows where we got a discount after total bill column by subtracting 2 from every row of total bill. So this was 16.99, this is 14.99. This is 10.34 minus 2, 8.34. Can you see that? 21.01, I am calculating 19.01, which means minus 2. So all these rows contains a new column, and this new column, the name is lengthy. I want to rename this discount after total bill to, I want to go and rename with a new name. Maybe I'll say final bill. So to achieve that, I will use another function called with column renamed. So with column renamed is going to rename old column with new column. So when I run this, my data frame will be overwritten. Let us try to see. It has been created. So if I go back and display the data frame, you will see a last column as final bill. Can you see that? Everyone? This column was discount after total bill, and I renamed this column name with final bill. If you see that, Everyone? Which function is helping us here? The with column renamed function. With column renamed is helping us to rename an existing column with the new column name. And all these are data frame operations. How to filter the data? I can even filter. If you remember, we discussed about a function called query in pandas. Whatever query will do, filter will do the same here. So data frame name dot filter, and I am applying total bill greater than 30 and a time equal to dinner. So these conditions will be applied, and only the rows matching this criteria will be selected. And out of all these rows, we are not going to select every column. I will select only these 4 columns which are required for my analysis. So I am using select and then in square bracket what are all the columns available, and finally I am saying show, which is going to display me. These are all the rows. So whatever you see here, this is the total, the customers with total bill greater than $30 and dinner time which they visited. Correct, right? I can also add one more condition here. What I can say, and day equal to Saturday only. I want only Saturday, not Sunday. See, these are all the customers' bills on Saturdays. And that too, the total bill for which the total bill is greater than 30 plus on the dinner time. Okay, if we give lunch here, it will show me lunchtime customers. See, there are no customers who are on Saturdays who visited during lunchtime and who are paying like more than who paying more than $30. So like that, that is how you can filter the data. Clear? I'll stop here and I will try to show you the aggregation part and the Spark SQL tomorrow. But I want you to try this. You can use this Google Colab and you can upload this particular file into this Google Colab environment where we can use this button, download the file I'm going to share, and then upload that here by using this button. And once it will come in your cloud environment, click it and it will automatically open. Then you can execute your commands one by one. And the input files which you receive should be, you right click and then upload. And once you upload, those files will be available, and copy, right click, copy path, and use the same path while loading the data. So this is the path. I hope that is clear, everyone. Yes or no? Will you practice?
Yes, sir.
I will share the entire the script and the input file, which you need to load it and need to run the commands, and you will receive an assignment also with another file. Similar use case, please even work on that also. Clear? So I received yesterday's assessment from only few people who not yet submitted. I want them to submit today. Who are not submitted? Who has submitted? I'm checking that. Thanks for that. And who are not submitted? I want them to submit today. Who needs to submit the assessment?
I have submitted.
Okay.
Submitted as submitted.
Okay. Who else is pending? Anybody pending? Because when I saw in the morning, I see only few people submitted. Ram, Sakshna, Uma. Okay. Okay, I'll check it anyway. So please try to work on what we discussed today, and we'll continue tomorrow, and we'll discuss about the Spark RDDs and Spark SQL. Thank you so much.
Thank you, Sri.
Yeah, thank you.